Okay, good afternoon to everyone. So is my AV is okay? Is my AV is okay? Okay, thank you, Abhishek. Okay, fine. So let us start today's class. So yesterday we were solving one numerical problem. So till this point we have done PG1, PG2. For first case we have done, isn't it? Now the second case we have to find out. So till this point I think we have done it. Okay. Now let us continue today's class. So the first question has been asked, what is the generation scheduling for the load? So that's what has been asked. So also there are some other questions are also, you see here, these are the questions which has been asked. So this is what we have done yesterday's class. Required generation for each plant. That is what is PG1, what is PG2, and the power received by the load. So what is the power received by the load? So this is what we have done yesterday's class. So there is another two questions are also there with the load obtained at bus 2. That means from this question we are going to obtain what is the load. What is the load at bus 2? So with that load, find the optimum load distribution between two plants. That means what is PG1, what is PG2 with this particular load when the losses are included but not coordinated. When the losses are included but not coordinated. Losses are also coordinated. Understood? So losses are also considered. Also find the savings in rupees per hour when losses are coordinated. Savings in rupees per hour we have to find out. So let us see that one. So these are the two cases we are going to see. Now yesterday we have done that one. What is the PG1, what is PG2, and what is the power received by this load. And whatever the load we have calculated here from this question with that condition, now losses are coordinated, losses are not coordinated. So with these two things we have to find out. Okay. So let us see here. So all these things we have done yesterday till this point. This is the first point. You see here PG1, PG2 for first question, and this is the power received by the load. So with this load 237.04 megawatt, case A, case B. Case B losses are coordinated, sorry, not coordinated. Case B is losses are coordinated. So losses are coordinated means when the losses are included. So case A first when the losses are not included. So when the losses are not considered, what is the optimal dispatch condition? What is the optimal dispatch condition? Is all the incremental fuel costs are equal. All the incremental fuel costs are equal. Okay. So that is the thing we have seen. So incremental cost means what? IC. We have represented that EC1 by
ಇದು
DPG.
ಉದ್ದು ಕಟ್ಸಿದಾಗದಿದ ಅದ್ರ ಮೇಕೊಂದು ಉದ್ದು ಪಡ್ಡಿ ಪಡ್ಡಿ ಆಗದಾಗ ಹಂಗ್ ಹೋಗ್ತದೆ ಹಂಗ್ ನೋಡಕ್ಕೆ
Okay. So when losses are not coordinated, not included, so considered. So this is the criteria for optimal dispatch. Understood? All the incremental cost of all the plants are equal, isn't it? So therefore IC1 is equal to IC2, because there it is a two plant problem. So under this condition, so you substitute the values. So what is IC1? IC1, that is DC1 by DPG1. DC1 by DPG1 is your incremental cost, which has been given in the problem. 0.02 PG1 plus 16 is equal to, what is IC2? Is nothing but your DC2 by DPG2. So that is given by 0.04 Pg2 plus 20. Understood? So call that as equation 1 here. So because this is the condition for optimal criteria when the losses are not coordinated. Clear? So our condition is IC is equal, IC1 is equal to IC2. So now given equations equate it. Now this is the first equation. Now what is the power delivered to the load? What is the total power delivered to the load? It is from your power balance equation. From your power balance equation, what is the power delivered? So here you can see total generation is equal to load plus loss. This is the equation, isn't it? This is the power balance equation. I said yesterday also, now once I am repeating it. Keep it in mind, power balance equation means total generation is equal to total load plus losses. Understood? So total generation is what? There are two plants, PG1 plus PG2 is equal to loss plus load. Is it clear? So from this one, you know PG1, we have PG2, we have to determine under this condition, under case A. We have to find out. You cannot substitute these values. Understood? So therefore PG1 plus PG2 is equal to, now for this particular load, we have to determine 237.04 plus loss. What is the loss? We have seen it here. In the previous slide, we have seen what is our loss equation for the given problem. This is the loss equation we got, isn't it? What is B11? You know that 0.001 that has been given. So that value we have to substitute it here. 0.001 into Pg1 square. This is the equation 2. Understood? So now here you see this is Pg1, Pg2. Here also Pg1, Pg2 are there from these equations 1 and 2. Now solve this equation 1 and 2. So we will get Pg1 and Pg2. That means you take what is the value of Pg2 from this one, So you will get a equation 0.02 Pg1 plus 16 minus 20 divided by 0.04 is Pg2. Substitute here Pg2. So you will get it in terms of Pg1. Solve for Pg1. Either way, or you take what is Pg1 is equal to. So replace Pg1 with respect to Pg2, or Pg2 with respect to Pg1, you replace it. However, it is up to you. You solve these two equations. Okay. So then after solving these two 1 and 2, you are going to get Pg1 and Pg2. Can anyone tell what is the value? Solve this equation 1 and 2. Tell me the value. First, solve equation 1 and 2. And you tell me what is the value of Pg1 and Pg2. Because simply if I am giving the values, if people will not learn. At least those people, okay, I am getting the answers. Fine. Sushumna has given the answers. So others, please calculate it and give me the answer. What is Pg1 and Pg2? Solving equation 1 and 2. Fast. Others, please calculate it. These are the two equations that has been given in terms of Pg1 and Pg2. Okay. Now you solve this equation 1 and 2 and tell me the values of Pg1 and Pg2. So these are some equations, just two equations are there. Using your basic mathematical knowledge, so you can solve this 1 and 2. As per your method, you can solve, or the method which I told you, you can use that one and you can solve it. It is up to you. Any answers? So otherwise, let me move on. Okay, fine. So the answers has been given by Sushumna is 275.18. Is it PG1 or PG2? 37.594 is the second answer. Which is among these two answers, which is PG1, which is PG2? First one is PG1. Okay, PG1 is 275.18. So PG2 is 37.594. Okay, fine. Thank you. So this is the answers that has been given. So this is the answer. It's the right answer. So solving these two, you are going to get Pg1 is equal to 275.18 megawatt and Pg2 is equal to 37.59 megawatt. Is it clear? So remember these values. Remember these values when the losses are not coordinated. So this is Pg1 and this is your Pg2. And what is this Pg1, Pg2? What we have determined here, when it is supplying a loss of 10 megawatt. Understood? So that we will see that one later. So when we have to use it. Keep these values in memory. Now let us move on to case B. What is case B? When the losses are coordinated. When the losses are coordinated. So when the losses are coordinated, so already we have done what is the optimal scheduling. Already the first one, that is PG1, PG2. Just now I explained these values. Already we have done this PG1, PG2 are the values we got when already we have considered the losses, isn't it? So this is the answer for PG1 and PG2. Optimal loading with losses, this is what you got it. So without losses, the previous one. With losses, already we got this PG1 and PG2. Fine. Now what is the question they have asked? So the savings we have to find out. So already one numerical problem we have done it under when losses are not considered, isn't it? Okay. Anyway, I am writing these values. What is this values? 275 and 37.5. This is case A values. Case A values. These are the case A generation optimal scheduling values, PG1 and PG2, because these are required here. Okay, now let us see. Loss coordination causes the load on plant 1. Plant 1. See, loss coordination, when you are considering the losses, then you see at plant 1 reduces from 275.18 megawatt to 128. You see, this is PG1, this is PG1, isn't it? So this PG1 is when losses are coordinated. Sorry, when the losses are not coordinated, isn't it? And this 128.57 is when the losses are considered. When the losses are coordinated, that means considered. So therefore, at plant 1, so you see the generation has reduced from 275 point something to 128.57. Understood? Similarly, what about at plant 2? What about at plant 2? So this is the generation without losses. Understood? And this is the generation at plant 2 with the losses. So therefore, what happened to the generation at 2, plant 2? It is increased from 37.59 megawatt to 128 megawatt. Hope you understood this statement. So when the losses, if you are coordinating, so at plant 1, the generation has reduced from 275 to 128 and generation has increased at plant 2 from 37.59 to 125 megawatt. For that purpose only, I will written these values here again. Clear? So that's what we have written it. Now therefore saving at plant 1 due to loss coordination. So what is the savings? What is the savings at plant 1 alone because of this loss coordination? So how to get the cost? First you should get the cost. How to get the cost equation is the unit of cost is what? Unit of cost. So you have to get the unit of cost in order to determine the savings. Savings means it is cost, isn't it? So what is the unit of cost? It is rupees per hour. Tushar has given that answer. So rupees per hour. So how to get this one? In the earlier class, when the losses are neglecting losses, we have got the optimal condition for optimal generation. That is, all the incremental fuel costs are equal. Clear? All the incremental fuel costs are equal. There we have solved it. One problem, isn't it? So how to get that one? Is there any cost equation available? Is there any cost equation available in the given problem? It is not available, isn't it? Is cost equation has been given? No. It has been given. Incremental fuel cost equations has been given in the problem. You see there. Earlier, the cost equation may be given and you have to take differentiation of that one. So then you will get incremental fuel cost, IC or DC1 by DPG1 like that. Here there is no cost equation to find out the savings. So how to move forward? How to get the cost equation? How to move forward? Can anyone tell? If cost equation is directly, we would have substituted Pg1, Pg2, what we got it here in the cost equation. However, cost equation is not there here. But here we have to find out the savings. So how to get back that one? How to get this rupees per hour? Now, rupees per hour equation is not available in the given problem. However, incremental fuel cost equation is available. Yes, Tushar has given the answer. Any others? Others? I'm giving the hint here. When cost equation has been given, you are going to get incremental fuel cost by differentiating the cost equation. Fine. Now here there is no cost equation in the given problem. However, incremental fuel cost has been given. So how to get the cost back? Cost equation. This is my question. I've given the clear hint. The answer lies in my statement itself. I want the answers from others also. Already Tushar has given some answer. How to get the cost equation? I think Sushumna has given. Okay, fine. So let us move on. So both Tushar and Sushumna has given the right answer. So we have to integrate the incremental fuel cost equation. Increment the IC equation, that is DC1 by DPG1, DC2 by DPG2. Separately, independently, you integrate so that you will get back the cost equation. Understood? So that's what we are doing it here. Now this is the integration. We are doing it here. So what is this one? You can see here. Somebody with QCOM-BTD is trying to log in. If your classmates are trying, please inform them. I will be not permitting with such names. QCOM-BTD. Yesterday also tried to log in. So if any of your friends are there, please inform them. I will not permit such unauthorized names here. Okay, so integrate integrating the DC1 by DPG1. DC1, what is the DC1 by DPG1? First incremental cost 0.02 PG1 plus 16 with respect to DPG1, integrate it with respect to this one with respect to DPG1 over the limits, because here there are two cases are there. There are two cases are there, isn't it? So what are those cases? The first case is 128. That means 128.57 to 275.18. That means when the losses are coordinated, lower limit, upper limit when the losses are not coordinated. So that is 275.18. These are the limits. Over these limits, you integrate the incremental cost so that you will get the savings between these two costs. Why we have represented limits? Because we want to see the question savings. So what is the savings when PG1 is equal to 275 and PG1 is equal to 128 at plant 1? What are the savings at plant 1 alone we are trying to solve? Now integrate this one with respect to PG1. Substitute the limits, integrate this one with respect to PG1, substitute the limits, upper limit and lower limit. Tell me what is PG1, what is savings in rupees per hour. So here on LHS side, you can write savings at plant 1. On LHS side, you can write savings at plant 1 is equal to, savings at plant 1 is equal to, you write that equation. Clear? Oh, Tushar already given 2937.7 unit. What is a unit? See, please always don't forget to represent the unit. If you won't represent the units, even answer is right, you will not get marks. Per hour? No. So others, please calculate, integrate. We are substituting the upper limit, lower limit here because we are trying to find out savings between these two generations. Case A to case B, like that we are trying to do it. This is case A, case B. Okay, Shanti Prasad has given the answer. So both of them has given. Okay, right. Tushar, you have corrected yourself. 2937.7 rupees per hour. So that is the answer they have given it. Let us see here. What is the answer? Integrating. So you are going to get 0.01 PG1 square. Why? Because PG1 square by 2 after integrating. So you will get 0.01 PG1 square, 16 PG1. So I am unable to show it here. Now I will use this one and I will show it here. And over the limits. So what you have to substitute here? It is 128 here 0.5. So substitute these limits, and here this is how you show it, because I could not show this fashion using the equation editor. 275.18. Okay. So this is how you show it. 0.1 PG1 square plus 16 PG1 over the limits 128.5 to 275.18. Clear? Abhishek has given 2560.7 rupees per hour. So let us check that one. So this is after integrating and substitute the limits. Understood? So after substituting PG1 is equal to these values, upper limit and lower limit, you know after integrating how to substitute the limits, isn't it? So after substituting, if you don't know, please learn that one, not an issue. Okay, so this is the answer you are going to get, 2937.69 per hour. That is rupees 2937.69 per hour is the savings at plant 1 alone. Why? Because from case A to case B, This is case B value, and this is case A when the losses are not coordinated. So case A to case B, case A to case B limits you have to put it here. So this is the savings. Now similarly, you find out the savings at plant 2, savings at plant 2. Similarly, you find out savings at plant 2 and you tell me the answer. That means again same, integrate the second incremental fuel cost over the limits. Now you decide which limits. Substitute it and you tell me what is PG2. So from this one, sorry, not PG2, savings at plant 2. Similarly, savings at plant 2 due to loss coordination. Okay, you see at plant 2 load increased from 37.59 to 125 megawatt. So what is the savings at plant 2? Tushar has given, Gunasmita, Shanti Prasad is having some doubt there. $2032.43 rupees per hour is the Gunasmita's value, and Tushar has given minus of 2032.4 negative sign, and the same doubt Shanti Prasad is also asking. He is also getting negative value. Gunasmita is not has got positive value, it appears to be. Others, at least, I will tell you, Tushar. Wait, I will show you the answer. Shanti Prasad also given the same answer, that one of Tushar with negative sign. Any others? Others? Answer is right, only the problem is with the sign. Now answer, whether it is right or wrong, I will tell you. But now Sushumna has given 1682.8. Taken lower limit as 37.5 and upper limit as 125. Gunaspita said she has taken lower limit as 37.59 and upper limit as 125. Now savings are planned too, so I am giving it here. See here, 0.04 Pg2 plus 20 of dPg2. So now you do it. This is case A limit, case B limit, case A, case B. So lower limit will be when the losses are coordinated. Upper limit will be when the losses are not coordinated. That is the equation we have to take it. Okay. Okay, now hope you understood. So negative, positive, there is a confusion over. So now I have represented this one, the limits 125 to 37.59. So that is case A, case B, isn't it? So 37.59. You see here upper limit is 275. So obviously upper limit should be 37.59. So lower limit is here 128. So here also lower limit should be this 125. Understood? So case A, case B. Losses are not coordinated, losses are coordinated. So now this is the answer you are going to get. This is after integration you are going to get. So this is the answer you are getting it, 2032.43. Okay, fine. So let me correct it here. Let me correct it. Some correction is required here. So it's not going back. Okay, fine. So now I corrected. You see this one minus rupees 2032.43 minus. See, even though we say savings, savings may be plus or minus. If plus is there, actually it is saving. So minus means it is as a loss, actually it is savings in loss. Understood? Why? You see the generation is been increased already. Plant 2, at plant 2 you can see here, using any of our basic knowledge, you can see the generation has increased. So therefore, if generation is increased, obviously, so the generation cost will be increasing. So that means it will be a loss over there. Understood? So that is what negative we are getting it. But the term we are using it is saving. Savings is minus rupees 2032.43. We are getting it. Now, what is the overall saving? So this is at plant 1 and this is at plant 2. Understood? Now, is there any overall saving of the plant? Is there any overall savings? What will be the overall saving? So therefore, overall saving, the net savings achieved by coordinating losses while scheduling the receiving load of 237.04 megawatt is equal to, now you can see it is 905.26. The difference between these two. Understood? 2937 minus 2032. Understood? Here it is plus sign, here it is minus sign. So that means here it is a loss, here it is a gain. So therefore, gain minus loss is your 905.26 rupees per hour. This is the net savings which has been achieved to supply a load of 237.04 megawatt. Is it clear? Hope you understood this one. Whenever two cases are there, in order to get cost equation, integrate that one over these two case limits. Then you find out the net savings here. Actually, to say this is not saving, this is a loss at plant 2 and this is a gain at plant 1. So gain minus loss is the overall profit or overall savings is 905.26. So this is the answer. You have to get it. Hope you understood this one. So otherwise, sometimes what they will do, they may not give, they may ask you to do it here. Okay. Okay, fine. Let me delete this one. Okay, fine. Sometimes what they will do, no? So they will not give this question. Understood? They will give lambda value, but this question they will not ask. Find the required generation for each plant and the power received by load. No, they will not ask here. So they will ask only these two questions. Only these two questions. So therefore, this question, same, we have done it. Now coming back to this question, So whatever the steps we have followed for this question, you have to follow it here. That is only the difference. Don't be the under impression that okay, this question has been not asked, load has been not asked. So most of the majority of the students, they will say, sir, load is not specified, isn't it? So even though this question is not there, just let me strike it off. Even though this question will not be there. Okay. The system lambda value will be given. Still it holds good. Still it holds good. So if this is asked, when the losses are included, you know IC1 is equal to IC2, equate these two equations. Then you solve for PG1, PG2, you will get that one using the things. Understood? So, but at the same time, when the losses are coordinated, before going to this one, because losses are coordinated only in case B. So, the same procedure, whatever you have followed for this question, you have to follow it. Understood? But here in this case, already question has been asked. So, we have not shown any steps under this question. Already we got PG1 and PG2 values when the losses are coordinated from this question. So, the same thing we have done it. So please remember that one. Even without this question also, you have to follow the same steps. Hope you understood this one. This is the assignment problem once again. Okay. There is a one numerical example I have taken it. We will try to solve some more numericals which are given at the end of the textbook, that is modern power systems. Okay, next topic will be derivation of transmission loss formula. So what is it? Already we have seen the transmission losses are considered by representing some loss coefficients. Loss coefficients, that is known as B coefficients, isn't it? B coefficients, loss coefficients are nothing but your B coefficients. So these loss coefficients may be represented in the form of index, that is two summation marks, or in the form of matrix P transpose into B into P in the matrix form, isn't it? So all these are the representation. I said there are several ways. So out of several ways, so we are going to derive this transmission loss formula. So appropriately, we are going to derive the transmission loss formula. However, the detailed analysis to derive this one, it is beyond your curriculum. It is not required. What is required is transmission loss formula. So we are going to get the formula for your transmission loss PL. Understood? So what we have done earlier, taking matrix index form, was a just approximate. So here we will try to get some one method which will give you almost exact transmission loss formula. So I think it is time is running out. Today I may not be in a position to start. So this transmission formula is an accurate method and it's a general formula for transmission loss which has been given by a scientist called Kron, K-R-O-N. So why I am giving the scientist name Kron means, so in the competitive exams they will be asking who has given the accurate transmission loss formula, objective type questions. So for that purpose I have mentioned the scientist name here, Kron. So I have seen some competitive exam questions. So this transmission loss formula, accurate formula, which is in general formula, is been given by Kron. So how to get this transmission loss formula? Because again it will come, if I start now, it will become incomplete. So I am going to start with a fresh class, this derivation of transmission loss formula. So I'll be continuing it in the next class. So any doubts, if you are having it, put it in a chat box. Otherwise, we will end the class. Okay. Thank you, one and all. Take care. Bye.